Hello, welcome to the class on the rock cycle. Okay, I'm Laura Lewis. Let's get started. So let's have a look at what we're doing today. So an understanding of the rock cycle and how the three different types of rock are formed. Number 2, the effects of crystal size of igneous rocks and the processes that lead to the texture of metamorphic rocks. And number 3, how to answer questions on the rock cycle. So the rock cycle overview. Okay, so you can see that and also the word cycle, because obviously that the rocks are recycled, so it goes around. So that the water cycle is that the rocks don't disappear forever, they're transported or transformed into something else. Okay, so you can first of all see, you start with the igneous rock there. Okay, so the igneous rock is either formed under the ground, which we're going to talk about a bit later, or is formed from volcanoes erupting and cooling down. So igneous rock and volcanic rocks, but they can also form under the ground from magma, which have solidified under the ground. We're going to a bit more about that in the other slides. Okay, so you have weathering of rocks at the surface by rain and wind, erosion and transport. Rocks are blown down into rivers, deposition of sediment, burial and compaction, so they get buried and compacted, and that forms sedimentary rock. Sedimentary rock can also form the beach level, it can form on land, but also form under the sea. Sedimentary rock, deformation, so it's deformed, and metamorphism, that you'll go into more detail, to form metamorphic rock. Okay, and then tectonic plates take this underneath the earth again, and it melts because it's very hot under there, and it again forms into igneous rock. So yes, it's a cycle. So let's go into a bit more detail about the different kinds. There's a bit more detail to this. So igneous, the three types: born of fire, it means in Latin, often known as volcanic rocks. Sedimentary, made of sediments that have been compacted, such as mud and sand. And metamorphic, so metamorphose means to change, they've been changed. So they can either be sedimentary or igneous that have been changed or metamorphosed under heat and or pressure. So it could be both, it could be either. This is an interesting diagram of the rocks of the UK. So you can see here actually goes from sedimentary, metamorphic and igneous, it's categorized, but also by age. So the Cambrian rocks are the oldest rocks here, going up to the Cenozoic, that are the youngest rocks. Okay, so you can see the interesting thing here is look at the igneous rocks are in red. Okay, so it's all got dots of them. That's where magma is cooled below the surface. Okay, we'll come up to the surface. So in Scotland, you can see quite a lot. If you go down to Devon and Cornwall, you can see quite a lot too. Okay, so generally the rocks in the UK actually get younger from north to south. Okay, due to different earth movements and things, but you can find out what rocks and how old they are in your area from this map from the Geological Survey. Okay, igneous rocks. So we'll go for one at a time. So igneous rocks come in two types. Probably heard as they are seen on the map: intrusive, so formed under the surface of the earth, and extrusive, formed on the surface of the earth. So that's like magma that's cooled down, extrusive. So intrusive rocks have large crystals and form below the earth's surface in igneous intrusions. So when we look at that map with all the red dots, they're igneous intrusions, and the red splodges. Okay, so examples would be granite found in worktops and gabbro found in Scotland. So we've got gabbro, granite are intrusive igneous. Okay, so extrusive igneous have tiny or microscopic crystals and form some solidified lava at the Earth's surface. Examples would be obsidian. Okay, so it's often called volcanic glass because the crystals are so small you can't see them, and pumice. Okay, pumice on the left hand. Pumice, scoria, and tuff are quite similar. Okay, and they've also got a lot of air in it. Pumice, you might know it floats. It's because it's from lava with lots and lots of gas in it. Okay, but Because generally, the slower the cooling, the larger the crystals. If something forms underground, it generally cools down slowly, so you've got large crystals. Okay. So again, we'll look back a little bit of igneous, intrusive igneous that we have in the UK, down in Dartmoor there. So you've got igneous intrusions, and you've got granite found down there as well. So in the UK, we don't really have, well, we don't have any active volcanoes, but we have some extinct ones, like in Scotland, and some igneous intrusions. It doesn't erupt above the surface anymore here. Okay. Metamorphic. Okay, so we've got some examples here. So igneous or sedimentary that have been subject to heat, so a nearby intrusion. So those igneous intrusions we saw last time, and magma coming up from the mantle, they could change the rocks around them. Okay, or pressure, so mountain building events and tectonic activity. So plate tectonics could cause them to be changed. So example, if chalk is in contact with heat, so that igneous intrusion, marble is produced by the formation of crystals. So you've been using worktops and bathrooms and things, marble. So heat and pressure will change mudstone to slate, same type of slate people used to write on. Okay, and large pressures will change the humble mudstone into kyanite, a beautiful blue crystal. So the change can be quite dramatic. Okay, so this can actually be found in Scotland. Okay, the kyanite. So let's go and see the next slide. So how are sedimentary rocks made? So there's a few things going on with sedimentary. Also for geography. So sedimentary rocks are made from the broken pieces of other rocks. So in a way, they're not kind of their own rocks. So weathering. So we're looking at physical weathering here. The rocks have obviously been split apart. So it occurs due to changes in temperature. So in freeze-thaw weathering, this is kind of how it sounds, water gets into a crack in the rock. The water then freezes and expands, causing the rocks to crack. This also can happen to pipes, can't it, in winter? Water can freeze in the pipes, and you can actually crack them. So it can do the same to rocks. Okay, so it's an interesting one, causes very dramatic landscapes and things. So chemical weathering. So rain falls onto the rocks. Acid in the rain react with the rocks, wearing them away. Stalagmites and stalactites are caused by rain trickling through rocks. Okay, so stalactites, the ones that grow from the ceiling, and stalagmites grow from the ground. Have you ever wondered that? So biological weathering, the plant roots or animals burrowing may also break up rocks. So erosion and transport. Okay, so I like this picture of the boulder just sitting there, it's not about any moment it's going to fall down. So after weathering, the rocks move away from their parent rocks. So the bits of the rock move away from their parent rocks. The process of rock breaking and moving away is called erosion. So that's erosion when it gets broken away. Transport is when sediments travel far away from the parent rock. They may be carried away by water, ice, or wind. So glaciers, like frozen rivers, can actually transport a lot of rock. As you can see at that boulder there, you can see the trees in the back, it's quite big. Okay, a glacier transported the boulder and then melted, it's made of ice, well, the glacier is made of ice, leaving the boulder perched on top. You get these quite a lot actually in the UK and further north. It's called drop stones. You just get a random rock somewhere. It's usually from where a glacier melted. Okay, compaction, sedimentation. So the weights of sediments above squashes together the sediments below. Okay, so compaction is just when all the sediment builds up, so the sand or the mud builds up and it squashes the sediments below. So it's cementation. Another substance sticks the sediments together. Okay, so sometimes during the above processes, animals die and become trapped within the layers, especially in the sea. The hard parts of the animals, the shells or the bones, become fossilized. But this means that materials such as pyrite or silica, so that's type of sand, replaces the original shell or skeleton. So these dinosaur bones in the museum are not actually the original bones. Okay, they're mineral replaced. So they've actually been replaced in a natural way by minerals that have seeped into the bones. So you see here an ammonite. Ammonites are like squid or octopus in a shell. This is the shell of the ammonite. So the whole shell of the ammonite has been replaced by pyrite. Okay, so ammonites are animals similar to squid with shells that lived 150 million years ago. So if you're in the UK, you get lots of ammonites down on the Jurassic coast, so Dorset, and also Folkestone in Kent. You'll find lots of ammonites. So I think that one probably, and also other countries as well. I found quite a lot of different ammonites. They're very interesting to look at. And also, yeah, you see the process of sedimentation going on. So sedimentary rocks have many uses. So building material. So many buildings are made from sandstone, limestone, especially see it does weather a bit, even obviously when you use it as building materials. You often see that the building's been a bit weathered. Okay, so cement, chalk and mudstone are extracted to make cement. Okay, so in the south of England, we can go back and have a look. Good to reference. So we've actually got this is the green bit is a chalk. Okay, it's a Cretaceous deposit, and the yellow is a mudstone. So actually, these two together can actually make cement. So you've got a lot of cement industry going on down here. Okay, so actually, it's quite important for the economics of the area what the rocks are. You probably know the north of England. There's lots of there used to be lots of coal mining that used to occur because of the Carboniferous. So they're about 300 million years old. Carboniferous rocks. Okay, so you can see Durham Cathedral. I've actually never seen this in real life. It looks very impressive. It's built from limestone that is over 300 million years old. Okay, so very, very old material. So it's a checkpoint here because lots of things have been said, especially about sedimentary rocks. So to pause the video and to copy and complete this. Okay. Go to the next one. So sedimentary rocks are made of sediments. Examples of these are sand, mud, and shells or bones. Freeze-thaw weathering is an example of physical weathering. Chemical weathering is caused by acids in rain. Sediments are squashed together in the process of compaction. The mineralized remains of animals are known as fossils. Examples of sedimentary rocks are sandstone, mudstone, and limestone. Let's go back to, so we've gone through all the different types of rock. Let's go back to the original main thing. So let's see what we've talked about here. Okay, so some of igneous rocks. So now we know that the rocks that form underneath here in this igneous intrusion, you can see it's not getting to the surface, is it's also called a batholith. Okay, you may know from geography. Is under the ground it forms. It forms intrusive igneous. An example of that could be granite, okay, forming underneath here. Rocks under, so it can also be erupting in volcanoes, and you may get a rock such as obsidian or pumice forming at the surface here. So you can sort of, I encourage you to draw this and also to label it with other rocks, okay, that we've seen so far. So pumice, granite forming under the ground. This is what we see in Dartmoor, Scotland. You see this igneous intrusions. Gabbro also in Scotland. So we've got pumice and obsidian. Okay, so weathering of rocks at the surface. Remember we talked about, and I'd make notes on, physical and chemical weathering. So you can see with the rain, that's going to be chemical weathering with the rocks forming, it comes from caves, okay, with stalactites and stalagmites. Okay, and erosion and transport when the rocks break off. They travel down by wind. You can see sort of sand dunes, it's supposed to be here. We can travel down the rivers, down to the sea. Get deposition of sediment. So sand and mud builds up to form deposition of sediment. Okay, it's buried and compacted. So remember the pressure compacted together, that forms sedimentary rocks such as mudstone and sandstone. Okay, and sedimentary rock can also be influenced by other igneous intrusions, or we can see here this is a plate margin, so it can also be compressed and squashed to form marble. It can form slate, kyanite can be formed, then melted again, and it forms magma again. So remember, magma is underground, lava is at the surface. Okay, so thank you for listening to that lecture today, and I hope to see you in another video. Thank you. Goodbye.